Okay, guys, by this time you have taken your notes, and I hope that you put the equations from your notes into your notes. It's very important that you have these. We're going to be using them for your test and for today's assignment. So here we go. I am going to step you through the first couple on this sheet, and then I'm releasing you to do the other 8. Very important. Show me your work. I'm giving you the answers, but I want you to be able to work them, so show your work. So for the number one, a ball rolls off a desk at a speed of 3 meters per second and lands 0.4 seconds later. How far from the base of the desk does the ball land? How high is the desk? And what is the speed and angle of impact? So here we go. So first thing you always want to do, you're going to draw a picture of what you're doing. So here's your desk. Here's the ball, rolls off the desk and hits the ground. Here's the ground. Here's your desk. If you drop an imaginary vertical from where it starts, where it launched from the desk, rolls off the desk at a speed, so the velocity x, the speed in which it left the desk, is always going to be your initial. It's going to be equal to the velocity of x. So it leaves at 3 meters per second. So Vx, or velocity in the x direction, is 3 meters per second. It gives us time at 0.4 seconds. So go to your equations that are in your notes. Your delta x, which is the distance from where it started to where it landed. Your x component in this case is delta x equals your velocity in the x direction times time. You know this, it left the desk at 3 meters per second. It took 0.4 seconds for it to land on the ground. Please excuse the dog barking in the background. I can't get him to be quiet. So delta x is going to be 3 times 0.4. So you should get 1.2 meters per second. Or excuse me, meters. This is distance. The seconds cancel out. 1.2 meters from when it left the desk, and where it landed. Next question. How high is the desk? Well, this is your x, or excuse me, your y, your vertical component. How high is that desk? Go back to the equations that should be in your notes. Delta y is 1/2 g times time squared. So 1/2 times 9.81 meters per second squared times your time, 0.4 seconds, squared. Plug and play. You should, when you plug this in, get your delta y is 0.78 meters. There you go. That is how tall this desk is. So we have solved your x and y. X is 1.2 meters. Your y is 0.78 meters. Your vectors are distance. They're both in meters for x and y. Okay. If I were to plug in x and y, these, into Pythagorean's theorem, it's going to give me distance. Okay. But I want to know velocity. I want to know the velocity in which it hits. And remember, when we're using vectors, it has to be apples to apples. It cannot be apples and oranges. I can't use a distance, meters, and a meters, another distance, to solve velocity. But I just solved, here's my desk, I'm just redrawing the same thing up there. There's the ground. I solved for x. So I need to solve the velocities. Okay, let me back up. I need to know the velocity of x, and I need to know the velocity of y to plug into Pythagoreans to find my final velocity of impact as it hits. And then I also, from that, can figure out the angle from horizontal in which it hit. Or I could say this angle. Okay? So, Vx. It already told me Vx. It left the table at 3 meters per second. Your initial velocity is always going to be equal to your x velocity. So for this one, I know it's 3 meters per second. What is my Vy? I need to know my Vy so I can have it to plug it in. If you go back and look at your notes, Vy squared equals 2 times g times y. And because this is a square, I'm going to take the square root of the other side. So this is going to be equal to the square root of 2 times 9.81 meters per second squared times my 0.78. I know it's kind of hard to read. I'm squishing it together there. If you go 2 times 9.81 times 0.78, take the square root of the entire thing, my velocity in the y direction is 3.9 meters per second. Okay. I know my x velocity. I know my y velocity. I can use those in Pythagorean theorem to find the magnitude of my final velocity, or what you would know as the hypotenuse. So we're just going to plug the whole thing in to Pythagorean's theorem. Vx, or my hypotenuse, which is my final velocity, is equal to the square root of 3.9 squared plus 3 squared. Plug all that in, and my final velocity is 4.9 meters per second. Okay, it's just strictly Pythagorean's theorem. Now, what's the angle? If this is the angle for velocity, or this is the angle, it's the same angle. If you remember back for geometry, it's going to be opposite over adjacent for tangent. So tangent theta, I'm looking for theta, or theta, same difference, they're both equal, is equal opposite, which is going to be my Vy, over adjacent, which is my Vx. So theta is going to equal inverse tangent, my opposite, which is my 3.9 divided by adjacent, which is 3. Okay. Take the inverse tan of this, and you should get 52.4 degrees. So we have just calculated how far from the desk did it land, how tall the desk was. Sorry about that, guys. We have figured out the velocity in the x direction, the velocity in the y direction, and we use those as vectors, solve for the hypotenuse to find the final velocity. and then we use those to find the angle. Okay? Again, you need to show your work. Okay? I gave you the answers so you'll know if you're doing it correctly. Okay, we're going to step you through the second one real quick. So, number 2, a slingshot is used to launch a stone horizontally from the top of a 20-meter cliff. So, here's our cliff. It's 20 meters tall. A slingshot is used to launch a stone. Okay. The stone lands 36 meters away from the cliff. So this, your X component, is 36 meters. Your Y component is 20 meters because it's 20 meters tall. It wants to know what is the speed in which it's launched. So what is your initial speed, which is also going to be your speed, or velocity, I should say, in the X direction. So, A wants to know your speed or velocity in the X direction. We know it's delta X divided by time. Okay? This is one of your equations. But we weren't given time. We don't know how long it took, so we need to calculate it out real quick. Back from a previous chapter. Delta y equals 1/2 g times squared. This was back from motion in one dimension. So I told you we're going to keep using the same equations. We're just going to build as we go. So here we go. If we're going to solve for time, I'm just going to rearrange this. The square root of 2 times delta y divided by g. So time is going to be 2 times my 20 meters divided by 9.81 meters per second squared. And take the square root of this whole thing. So time is going to be 2 seconds. Now, take this, plug it in here. My velocity in the X direction, my X velocity, is going to be 36, because it landed 36 meters out, over time. So my initial, which is also equal to my velocity in the X direction, is 18 meters per second. Okay. Now, it wants to know the speed and angle of impact. In order to find the speed and angle of impact, we know the speed for the X. This velocity X, because remember we need apples to apples, is 18 meters per second. We want to find the hypotenuse, but in order to use Pythagorean's theorem, we need to know the velocity in the Y direction to plug it in. So, go back, delta Y, velocity in the Y direction is going to equal, sorry, I'm going to pause it a second. Okay, sorry about that. I had to pause. Cat got into something. So, here we go. In order to find, in order to plug this into Pythagorean's theorem, we need all velocities to find the velocity. So we know the X, it's 18 meters per second squared. We just calculated that out right here. We need to know the velocity in the Y direction. Well, go back to the equations. Velocity Y is equal to your G times T. You know G is 9.81. You know your time is 2. I can plug, and then I just plug and play. The velocity in the y direction is going to be 19.62. I'm going to go ahead and just round it up to 20 seconds for ease of use in this case. So here we go. You know your y, you know your y velocity, you know your x velocity. Now we're going to plug it in just in Pythagorean's theorem to find this. So your final velocity, Pythagorean's theorem, is going to be 18 squared plus 20 squared. Plug it in, take the square root. Your velocity final should end up to be, what did I say it was? 27 meters per second. Okay, you know that. And you also want to know the angle. Well, here's the cliff. Here's the slingshot. You want to know from horizontal what this angle is, which is this angle. Okay. You know the velocity is 18 meters per second in the x direction. You know this is 20 meters per second in the y direction. Inverse tangent of theta of this angle is equal opposite 20 meters per second squared over 18 meters per second squared. Units cancel out. 20 over 18, inverse tan. Okay, back to 20 over 18. And you're going to notice that your theta equals 48 degrees. So this angle here, or this one, same difference, 48 degrees. Okay, hopefully this helps. Again, I gave you your answers. I am mostly concerned with you showing your work. Very important. Okay? You can look up the answers online. I know that. But I want you to know how you got your answers. Okay? Any questions? Send me a message over Schoology. Thanks, guys.